In today's video, we're going to talk about parallelogram proofs. And what we're going to do is we're going to take the properties that we talked about in class and we're going to apply them to some proofs, or a couple proofs that we have. Now, the properties that we talked about are in the box. So in class, we talked about that parallelograms have opposite sides that are parallel. They have opposite sides that are congruent. They have opposite angles that are congruent. They have consecutive or adjacent angles that are supplementary, meaning that those angles next to each other are going to add up to 180 degrees. They have diagonals that bisect each other, and I really stress that that doesn't mean that the diagonals are congruent. It just means that they cut each other into two congruent parts. Number 6, a parallelogram has diagonals that divide the parallelogram into two congruent triangles. Now, let's take a look at number 1. Number 1 says JKLM is and that's a symbol for parallelogram. So what I'm going to do, and what you should do, I'm going to highlight that. So if you're a person that likes to use different colors, now might be a good time for you to pause the video and get those colored pencils out or highlighters. Okay, the second piece of information that's given to me is that JO is congruent to OL. So I'm going to mark that. I'm going to mark that JO is congruent to OL. I have to prove that OP, all right, this segment here, is congruent to OQ. All right, now, something that should pop out at me is that I can prove that those two segments are congruent if I prove, and go back to my highlighter, that these two triangles are congruent. That's one, and then that's the other. Okay, now, so let's break apart or mark up some other information, because that's the way we should approach these proofs. Other information that we have. Well, we know, and I'm going to put 3, this angle here, and 4 are congruent. All right, those angles are congruent because they're vertical. What else do we know? We know that, and it's already a 1 and 2 there, we know that, make this nice and thin, angle 1 is congruent to angle 2. Well, why? This line, JL, is a transversal because I have JK is parallel to ML because opposite sides of the parallelogram are parallel. So I know that angle 1 and angle 2 are congruent because of alternate interior angles. So now I'm ready to write up my proof, because I'm going to prove that the two triangles are congruent through angle, side, angle. So I already have my bar set up. So I'm going to do my statement. And reason. All right, so I'm ready for my 2-column proofs. If you are a floater, if you like to float with the proofs, go right ahead. All right, now, so the first thing I'm going to write is that JKLM is a parallelogram. I'm going to use a symbol. And I'm also going to write that JO is congruent to OL. Okay, and the reason for that is given. Number 2, I'm going to put down that angle 1 is congruent to angle 2. And the reason for that is because alternate interior angles are congruent. And I can put with parallel lines. Number 3, I'm going to list that angle 3 is congruent to angle 4. And that reason is vertical angles are congruent. All right, number 4, I can go ahead now and say that triangle JOP is congruent to triangle LOQ. And that reason is angle side angle. My last important statement, which students sometimes forget, is the actual proof that segment OP is congruent to segment OQ. OQ. And that reason is our favorite CPC-TC. All right, let's go down to example number 2. All right, number 2 gets a little messy, so let's hang together here. We'll get through this. So it says ABCD is a parallelogram. So again, let's highlight that. So A, B, C, D is a parallelogram. All right. It says D is the midpoint of D. No, it's not DE. It's supposed to be AE. So make a change there. So that's AE. All right, so D is the midpoint. So I'm going to mark that AD is congruent to ED because of definition of midpoint. Now it says prove that triangle DCE, I need to mark that. Where is that triangle? All right, so DCE is congruent to CDB. CDB. Messy with the colors, but I really love it. I really think it brings out what we're looking to do here. And it also should bring out a couple things you should see right away that we're going to need in our proof. All right, now, so let's go through. How am I going to approach this? Well, if I know that opposite sides of a parallelogram are congruent, all right, so I know that AD is congruent to BC, and I know that D is the midpoint of AE, then I can get BC being congruent to DE through substitution. And I'll show that in 1 second. I also know that DC is shared by both. That's the beauty of these colors, showing that these two lines are reflexive. All right, now, I can extend the lines, and it really helps to do that and to see where we're going here. So if I extend those parallel lines, wow, I kind of like this. All right, so if I extend the lines, then I can see that DC, all right, that reflexive is actually, it's a transversal. So if it's a transversal, then I know that I have alternate interior angles. So I'm gonna make this skinny, I did. So I'm gonna call this angle 1 and angle 2. Oops. I need this one, sorry. 1 and then 2. All right, angle 1 and angle 2. All right, so just going back. All right, so I have BC being congruent to DE through substitution. I have my reflexive DC, all right, reflexive property. They share that same side, the two triangles. And then that side there that shared that reflexive side, DC, is also transversal through my extended parallel lines. Then I have angle 1 being congruent to angle 2 through alternate interior angles. Alternate interior angles are congruent when I have parallel lines. All right, so I'm ready to write up. So let's go. So I have statement and reason. First statement, I'm going to write my given that AB CD is a parallelogram. I'm going to do the symbol. All right, and that's given. 2, I'm going to write D is the midpoint. Whoa, movement. So it's the midpoint of line AE, and that also is given. All right, 3. AD, segment AD is congruent to ED. And I'm going to write definition of midpoint. All right, I'm going to write AD. AD is congruent to BC. Segment AD is congruent to segment BC. And that's because opposite sides of a parallelogram are congruent. 5, now I can do my substitution. So ED now is congruent to BC. And that's substitution. 6, I'm going to write DC. Segment DC is congruent to segment DC. And we all know that is a reflexive property. 7, angle 1. So angle 1 is congruent to angle 2. And 7 is alternate interior angles. Are congruent. And 8, I can say that triangle DCE is congruent to triangle CDB. And the reason for that is side angle side. All right, so I have my side, my angle, and my side. Okay, what I want you to do is write down some key ideas. I want you to try that proof, check your understanding. All right, just break it down, highlight. All right, fill in the information that's given, fill in the information that you know from your knowledge of parallelograms and from your past, and please try and prove that those two triangles are congruent. Go Cats, go Knights.